Good morning, everybody. I wanted to send you a quick video to help you out with today's math assignment. So everything we're doing over the next few days is just quick reviews over material that we already learned this year. But I know it's been a little while, so I just wanted to go over the stuff with you real quick to help you out in case you've forgotten any of it, okay? So with each of these, I provide you with a cheat sheet that will help you to answer your problem. So refer back to the cheat sheet and that'll help you. So the first thing that it's going to go over here is our exponent rules. So with our exponent rules, remember when we multiply, we add. So when we multiply the bases, we add the exponents. Let me see if I can get my little tool back here. So when we multiply the base, which is that x, and we add the exponents. Okay? When we divide, we subtract. And remember, that little line was our reminder that we needed to subtract. When it's a power to a power, we multiply. Remember, we used to do the thing where it was like multiple exponents multiply. And over here, let's see if I can drag this up here. There we go. Right here, whenever we have a negative exponent, remember we flip it. So if I had like 7 to the negative 2, which is this example right here, I would put it underneath a 1. Okay? All right. The next thing we've got here is our squares and square roots. You can use Google. If you go to Google and you type in scientific calculator, gives you a handy little calculator here that you can use to do your square roots. If I click this, maybe it gives me more. No. Another place you can find a scientific calculator is Desmos. So right here with Desmos, you have another scientific calculator that you can use to help you guys out with your exponents and your squares and your square roots and all that good stuff, okay? Right here is how you could use cubed roots. So if you need to take the cube root of a number, you click this button right here. You're going to need to put a 3 there because we are cube rooting this. And then you come right here and you type in the number that you need to take the cubed root of. Okay? Does everybody see how to do that? Let me know if you need any help. So Desmos would be a really great scientific calculator to help you guys out. So 9 squared, remember, if we're squaring a number, it's just like saying 9 times 9. If there's a negative inside of the parentheses, that negative gets trapped, so your answer would be a positive because it's kind of like saying negative 11 times negative 11. So a negative times a negative would give us a positive. And whenever we have this fraction squared, remember you do 2 squared over 3 squared, which would give us 4 over 9. Okay? Taking the square root of a number, we pretty much know our perfect squares now, so hopefully that'll help you out. Once again, use your Desmos calculator, use your iPhone. If you take your iPhone and you pull up your calculator, so if you pull up your calculator here, turn it to the side, you will get your scientific version of your iPhone calculator, and it actually has, let me see if I can get that on there, it actually has cube roots and square roots already on it. So if you have an iPhone, that's what I would use because it already has the square roots and cubed roots. Okay? The next thing on our review is scientific notation. So with scientific notation, remember that the number needs to be between 1 and 10, and then we raise it to a power of 10. So if I have this number here, let's try this one. Since it's a positive, so remember positive exponent, we move to the right. Negative, we move to the left. Okay, so our positive, I'm going to move it 1, 2, 3, 4, 5, 6 or I'm sorry, 7 places to the right, and that would give me this. This one has a negative exponent, so I would move it 7 places to the left, which would give me this. Okay? You hear Jace laughing. All right. Our operations with scientific notation, use this block right here to kind of help you remember the rules. Remember, bases do as they're told, exponents follow their own rules, okay? So when we are adding or subtracting, we need our exponents to be the same, and then we just add them as normal and keep the same exponent as long as they have the same exponent. If they do not have the same exponent, you would need to rearrange it so that they did. So you would maybe need to move your decimals so they were both to the power of 4. For this one, with multiplying and dividing, you are just going to follow your exponent rules. So bases follow the rules. So 1.2 times 3. Whenever we are multiplying, we add. So it would be 3 plus 9. Okay? It's been a little while since we've done this, but once again, this should be a review because we did this earlier in the year. So now what you're going to do is you're going to come over here. I've given you 2 attempts at this. So if you don't do so well, it doesn't tell you the correct answer, but it tells you the ones you miss. You are allowed to try to submit it a second time. If you still don't do that great, just send me a correction sheet on it and I'll give you your points back. So these are shuffled, so they are not going to be in the same order for you as they are for me. So I'm just going to go over them real quick for you. Just make sure you're paying attention to what number I'm on. So this one is actually number 5, and it says that Jet knows that x squared is equal to 64. Which of the following represents the step that Jet should take to find the correct answer? So if x squared equals 64, we need to isolate the variable, so we need to get rid of that square. So the way you do that is you do your inverse operation, and we just did this with our Pythagorean theorem. So how am I going to get rid of that square? Am I going to divide it by 2? Am I going to divide it by 4? Am I going to take the square root of it? Or am I going to take the cubed root of it? Remember, we want our inverse operation. So which one of those is that? All right, this one is actually number 6. So a single piece of paper weighs about 9.9 times 10 to the negative 3 pounds. Millie bought 5 packages of paper, and each package holds 300 pieces of paper. Find the total weight of the 5 packages expressed in standard notation. So first of all, you need to figure out which operation are you going to perform. So a single piece of paper is 9.9 times 10 to the negative 3 pounds. She bought 5 packages of paper, and each of them has 300 pieces of paper. Find the total weight of the 5 packages expressed in scientific notation. So she got 5 packages. Let me turn on my pen. So each package has 300 pieces of paper. And we know that each of those papers weighs 9.9 times 10 to the negative 3. So if each of those papers weighs 9.9 times 10 to the negative 3, and she bought 5 of them, how much total does it weigh? So I would need to find out, well, how much does each package of paper weigh? So 9.9 times 10 to the negative 3. Let's put that in standard notation. It's a negative 3, so I'm going to move it to the left. So that's how much it weighs. I'm going to multiply that by 300 because there are 300 pieces of paper. And that's when I would find how much each package weighs. Then multiply that number times 5. I think you guys can take it from there. The next one we've got here. A professional basketball stadium can hold, this is number 9, by the way, can hold 21,000 people. A motor racing venue can hold 8.5 times 10 to the 4th people. How many more people can the motor racing venue hold than the basketball stadium? You need to put them in the same format, either both in scientific or both in standard, and then subtract. Hi, Jay. For this one, follow your rules and figure out which.
Hi, Daddy. Hi, Daddy.
All right, let's try that again. Which of the following is true? So you're going to use your rules, your exponent rules, and figure out which one of these makes a true statement. When we multiply, we add. When we divide, we subtract. When we have multiple exponents, we multiply. And when we have a negative exponent, we flip it and put it under 1. All right, this one is number 7. So you're just going to follow your exponent rules and simplify the expression. Use your cheat sheet. For this one, how many times heavier is the largest airplane than the smallest airplane? So he's at an airport where the largest airplane weighs 3 times 10 to the 5th pounds and the smallest airplane weighs 12,500 pounds. You need to put both of these values either into standard notation or scientific notation, and then figure out the correct operation. It says how many times heavier. This is actually number 3. So Chantel read that the distance between the sun and Mercury is about 36 million miles. Which of the following correctly represents this distance in scientific notation? So you're just going to take 36 million, move your decimal. So you have 36 million. Move your decimal until you get it between 1 and 10. Count that and raise that to your power of 10. All right, this is actually number 4. So a theme park had 2 times 10 to the 7th guests. In the same year, a second theme park had approximately 4 times 10 to the 6th guests, which is a true statement about the number of guests that each had. So I recommend putting them both in standard notation and then figuring out which statement is true. And the last one, which value is equal to the cubed root of 729? Just put this one in your calculator. Either use Desmos or your iPhone and find the cubed root. Remember, it is the cubed root, so that's going to be a 3. That's not a square root. That's a cubed root. So make sure you do the cubed root. Okay? All right, if you guys get stuck on any of these or need any help, please don't hesitate to message me and let me know. Just make sure you send me a picture of the one that you're working on, because remember, they are shuffled. So your number 3 is not the same as my number 3. So make sure you send me a screenshot of the problem you are working on. Okay? I miss you guys so much. I really, really, truly do miss teaching you math. So please utilize me and message me so that I can help you guys any way that I can. All right? Love you all. Stay safe. Bye.